Okay, welcome back. We'll do problem 9.6. Now this is a very interesting problem. It says there are two equations and you have to indicate the area of this coordinate system where these two equations are inequations, I should call them, are satisfied. So the x and the y of which areas of the coordinate system will make these two equations work. So what I did start with is a simple table where I'm going to find the slope and the constant or the intercept of those two equations. Now inequations are given. I will replace those signs, greater than and less than equal to sign, with equality sign. That makes them equations, and then from there we will proceed to find what those inequations would look like. So let's start with the first one. Y equals minus x minus 1. Remember, we want to find the expression in the form y equals mx plus b, where m is the slope and b is the intercept. If you are not ready yet at this point, you're welcome to go back to the previous couple of problems where we have explained how to find m and how to use m and b. Okay, so by comparison to mx plus b, you can see m is minus 1 and b is also minus 1. In the next one, we have y equals 2x plus 1. Here m is 2 or positive 2 and b is positive 1. Okay, let's see if we can quickly write these equations or draw these equations on the coordinate axis. Okay, I've drawn the coordinate axis here, the coordinate system y and x. And I've also indicated the origin where we are starting to count. So let's see what m minus 1 and b of minus 1 mean. We know that b is the y-intercept, so if b has a negative value of 1, it should be this point. That line is passing through this point. Okay, and we also know that we can calculate the the x-intercept. The x-intercept is when y is 0. When y is 0, x is minus b over m. So we'll just add one more term here, minus b over m, and let's see what that value is. So if these are the two values, minus b over m would be minus 1, because b over m would be minus 1 over minus 1, which cancels, the signs cancel from the top and bottom, so you have left with 1 if it's just b over m, but minus b over m adds one more negative sign, so you get negative 1. And for the second one, let's calculate it right away. Minus b over m will be minus 1/2. Okay, so let's proceed. So this is minus b, and the x-intercept is minus 1. So let's see where the x-intercept is. It will be this one. In fact, you know what, because this origin, I don't really have to put a letter O here. I think you all know now, so let's leave it like that and redraw this line. Okay, so the line passing these 2 points would be this line. I'll draw it faintly for now. You will know why I drew it faintly. And for the next problem, b is 1, which means that the second line passes through this. This is its y-intercept, and its x-intercept is minus half. Now x-intercept minus half will be this point. It's in between the origin and this other point. So let's carefully draw this line. When you are drawing a line through 2 points, don't worry about these other points where the lie. Just focus on those 2 points. Make sure that your line passes through them. Okay, so let's make sure that we name these. This is L1 and this is L2. And let's also name here. The first one we drew is, this is L1. The second one we drew is L2. Okay. So these are the 2 lines. They intersect somewhere here. Okay, we don't really have to worry about it right now. Now the question is asking about the inequations. So y is greater than minus x minus 1. So all the points of this line is satisfying y equals minus x minus 1. So you can even write it here. Y equals minus x minus 1. So that means any y which is bigger than the y's on this line will make it greater than minus x minus 1. Any point you choose. Let's say you choose this point. Whatever y is, which is here, you can see that that's the y. It's probably about 2.6 or 2.7. Any y, let's say y is 3, which is this point, or y is 4, which is this point. It will satisfy this. So y cannot be on this line, but y has to be above this line. Okay, and the way to indicate it is we hash this area, this entire area at the top. We hash it to indicate that this whole region above this line L1, but not touching the L1, will be true for y greater than minus x minus 1. Okay, knowing that, we can even indicate it here. See, my arrow did not touch the line. Knowing that, what we can do next is look at the next one. Y is less than or equal to 2x minus or 2x plus 1. So since this is less than and equal to, all the points of line L2 will satisfy the equal to part of it. But less than means you have to look at any y. Let's say I choose this point. Any y less than would satisfy that. So it means that all the points, let's say even if I take it up and down here, that's your y is whatever that y value is. Let's see, it's 1, 2, 3, 4 and 5. So if I choose this point, y of negative 5, so a y which is less than negative 5, let's say this is y equal to minus 6 or minus 7 or minus 8. Any y which is less than negative 5 for this point will be okay with this inequality. So it means that all the points which are to the right of L2 will satisfy that equation, and also on L2. So we are going to indicate it like this. Now Let me unzoom so you can see all of it together. Now, which is the region of this coordinate system xy region? Which region is satisfying both this? Okay, that is what you have to find. We satisfy both the right of L2 and you can say above or to the right also of L1. So those two, those region is basically this region up to here and here, and anything to the right of that. But remember that points on L1 are not included, but points on L2 are included. So let's hash this. I'll take a moment to do that. Okay, I have hashed that space, which basically is to the right of L2 and above L1. Also, you can call it to the right of L1. Now, I have done something a little bit strange, which is that the part of L1 that we are thinking of, I dashed it. I made it a broken line instead of a continuous line. And the reason is, and this is a convention, some books use it, some do not. Some books start the hash marks right from the line, including the line, which means that points are included on the line. And they would just place a small gap between the line and the hash marks if the line points are not included, which is in this case for L1. Some other books which I have also seen is that they have used dashed lines or broken lines to indicate, but any points adjacent to the line and onward will be included. So that could be one convention that you can also follow. But this is a very important problem in my mind because it makes you think not just about the line, but about the entire coordinate space, which areas of the coordinate space will satisfy an inequation. So I think this is the first problem that we did with inequation graphing. Hope you enjoyed it. I have, I think, one more video that I am going to do next, and we'll close this topic for the time being, unless you have any questions or I have any interesting problems that I want to add to this topic.